So Grignard reagent reactions first of all, then Grignard reagent on treating with acidic hydrogen containing compounds, hydrocarbons will be formed. So what are those? I'll discuss once. Then I am taking RMJX, in which R group is acting as nucleophile. R means any alkyl group we can take, or phenyl group also we can take. First one, Grignard reagent on treating with H2O. What is the product? On D2O. Next one, alcohol I am taking. Here, phenol also we can take, carboxylic acid. Next, ammonia. Primary amine. Secondary amine. R may be equal to R dash, R may not be equal to R dash, both are maybe alkyl groups. Some more reactions we can take. These are reactions of acidic hydrogen containing compounds only I am taking, and nucleophilic addition reactions I will take separately. R dash, R double dash. Nitrogen is having one lone pair of electron. This is primary, RNH2. This is primary amine. This is secondary amine. This is tertiary amine. Well, again I am treating with alkyne. This is terminal alkyne. This is internal alkyne I have taken. This terminal alkyne and internal alkyne. You can also take phenol. Alkene I am taking. And benzoic acid. Then, generally, Grignard reagent on treating with H2O. H2O decomposing into H plus plus OH minus. H plus can react with R minus. RH will be formed. Plus. Mg plus can associate with whom? OH minus. Mg. OH. X. D2O. D plus plus OD minus. Same like H2O. In the place of D, in the place of hydrogen, deuterium we have to write RD. Mg. OD. X. Halogen. Then ROH. Whenever you take reactions of alcohol, then alcohol can participate in two types of reactions. Then we can cleave the bond between the R and oxygen, and we can also cleave the bond between the oxygen and hydrogen. R and oxygen and hydrogen. Then when is it possible and when do we have to follow this one? Whenever alcohol on treating with acid, then bond will be cleaved between the R and oxygen. Alcohol on treating with base or any metal. Then what is the nature of the base? Base is proton acceptor. That's why bond will be cleaved between the oxygen and hydrogen. So now, what have they given? R minus is given. R minus is also acting as conjugate base. Then whenever conjugate base is going to react with alcohol, that time it can take the proton from the alcohol, gives rise to R, H will be formed. Plus Mg, OR, halogen. Next, carboxylic acid. Carboxylic acid is decomposing into carboxylate and plus H plus. H plus can react with R minus, RH will be formed. Mg, OC double bond OR, halogen. Then NS3 is acting as base, can donate electron pair to the magnesium between the nitrogen and magnesium bond will be developed. That nitrogen gets positive charge, can take electron pair from the hydrogen, H plus will be released. Then whenever it is going to react with the conjugate base, H plus can react with R minus, RH will be formed. Mg remaining NH2 minus will be associating and X. In the place of 3 hydrogens, here only 2 hydrogens are there, one hydrogen is replaced by alkyl group. Here also in the place of 2 hydrogens, we can represent one alkyl group. RH, Mg, NH, R, halogen. Then here, only one hydrogen is there that can react with R minus Mg and R dash hydrogen. Next, here tertiary amine if you take, there is no acidic hydrogen, there is no hydrogen, that's why it does not react with the Grignard reagent. Then triple bond carbon is connected to hydrogen. So that hydrogen is acting as acidic hydrogen. We can explain the acidity based on the S character. R minus can react with H plus, RH will be developed. Mg, C triple bond Cr halogen. There is no acidic hydrogen, no reaction. Phenol can easily decompose into phenoxidine plus H plus. H plus can combine with R minus, RH will be formed. MgO benzene ring. Alkene does not react with the Grignard reagent because basic nature is not enough substance to pull the proton from that one. Carboxylic acid decomposing into benzoic acid is decomposing into benzoiodine plus H plus. Here also H plus is possible. RH plus benzoic acid salt will be formed. Okay, then remaining reactions, nucleophilic addition, I'll discuss in other topic.